Hello everyone, my name is Stephen Bell, aka Sakuyi, and welcome back to the official Dev Diary for Aura History Untold. Remember to go ahead and subscribe and hit that notification bell in order to receive alerts as we drop new episodes here every single week. And also be sure to sign up for the Insider Program. The Insider Program is free to everyone. You just need to go and fill out a survey with your PC specs in order to make sure that you meet the minimum requirements. As a fair warning, today's episode is going to be a little bit more technical than most that we've been covering, as we're going to be going into Oxide's proprietary Nitrous Engine, which has been designed to handle enormous amounts of visual and gameplay complexity, such as what is found in Aura History Untold. So speaking on this topic is none other than Dan Baker, the chief graphics architect and co-founder of Oxide Games. So Dan, welcome to the show.
Hi, thanks for having me. Really excited to be here and be able to geek out about some of the really cool technical stuff.
Now, before we get started, there seems to have been a change to your background. Is that a quilt?
Yes, behind me, over here, that is actually a quilt of Oxide that my mom made. My mom loves to sew. She sewed the entire time we were kids. She actually used to make our clothes for us, if you believe it or not. It didn't really save money, but it's just a hobby of hers. So when we started Oxide this a few years ago, she said, "Oh, I'm going to make you a quilt," and she refused to tell me how much time it took. You can see it looks really nice.
That does look really nice.
Conceivably, a lot of hours were spent making this quilt, and she was so nervous about it, mailing it, that she, when she came up for Thanksgiving, she just took it with her because she didn't want to mail it. And I was like, "Oh, they have insurance." She's like, "Yeah, but you can't replace it. It would take, who knows how many hours."
Not when it's handmade. That makes a lot of sense. Oh my gosh, that's amazing.
Yeah, it came out really nice.
Well, good job, Mom. Okay, so to kick things off, we would love to know more about your career in the games industry thus far. And some of our viewers may be unaware that you helped to develop Direct 3D, which is a huge part of DirectX for games on Windows and Xbox consoles. Can you tell us what any of that means and how that whole thing came about?
Wow, there's a whole lot of terms there. So my career actually started, believe it or not, in 1999. I was still in college, and I don't remember exactly how it happened, but I think one of my friends got a job at Microsoft, and then I applied for an internship, and then they asked me what I wanted to do, and I said, "Well, I want to do games," and the game industry wasn't that big then, so I got an interview with the DirectX team, and so I was an intern in 1999, and I just remember the first day I showed up. This is sort of a very unreal story, that I get into my boss's office, and on his desk is this open board computer thing with like. And it was basically a GeForce 2 with I don't know, one of the Intel CPUs, and it was a PC that could boot really fast. And I asked him, "Well, what is this thing?" "It's this prototype." He said, "Oh, well, this thing." Well, this thing is what we're calling an Xbox for the DirectX group. But that's just a code name. We're never going to call it that if we actually decide to make this thing. And I wish I had a picture. It was really cool. And so during the
that was the original Xbox?
It was the first Xbox. I saw the first Xbox on my boss's desk, and he was the one who named it. So I just remember, like, he was just really working on that, so I didn't get to see my boss a whole lot during the summer. And so I remember the day that, like, he disappeared one day because he had to do the pitch in front of Bill Gates. And it's a pretty nervous thing, right? You're pitching in front of Bill Gates at the time, who's the richest man in the world. He's still one of the richest people in the world. And so he disappears, and he comes back, and I didn't see him that day. And then he comes back the next day, and I asked him like how it went, and he said, "Oh, really, really well. I think we're gonna make this." So it was really interesting to be there when the Xbox actually got created, to see its inception. So that was kind of cool. So that's where I got my start. And after I did the internship, I finished up my degree. At that point, I said, "Well, I want to work in the DirectX group. I want to work on the technology for making games." And so then I started my career there. And while I was there, I worked on this, back some numbers I'll throw out here: DirectX 8, DirectX 8.1, and DirectX 9, which was really a really huge innovation. DirectX 9 is still used even to this day. It was we didn't realize how seminal it would be. And then DirectX 10, and then so I got my founding, my start at Microsoft working on the DirectX product, and then I decided, I really want to make games now, and I really loved actually Civilization. So I at that point I left Microsoft and went over. I moved all the way across the country, directly where my brother lives, and started working at Firaxis Games.
Dang. Okay, you have been involved in a lot. So I guess that would be one of the major gaming projects that you worked on before, was like Civilization and whatnot. Were there any others that you did besides that?
Yeah, so I'll talk a little about the games I made. So after I left Microsoft, went over to Firaxis Games and worked on a lot of products over there. A lot of the graphics tech, from Railroads to a few of the Civilization titles, some work on XCOM. It was a great time. I remember shipping Civilization 5. That was sort of a seminal moment, really pushed the envelope. And then about 10 years ago, we decided to start our own studio. And actually, it was in my basement in the first year, actually for 6 months. And the whole idea there was to sort of push the envelope of what PC games could do, because we really love PC games. That was part of the reason why I worked on DirectX, is this love of PC games. And so Oxide made a game called Ashes of the Singularity to get us started and to really prove out what our tech could do.
Okay, and with that covered, you have mentioned the Nitrous Engine. Let's go ahead and jump into that. Could you give us a basic rundown of Nitrous and why Oxide decided to create their own engine? Because, I mean, you just started your own new company, and now you had to add an entire game engine as well?
It's one of the reasons why people ask, how did you start your game company? I said, well, what we did was probably not repeatable, because when we started the game, the studio. One of the reasons we started it is, at the time, we really realized that there are a lot of great games getting made, especially with off-the-shelf tech, but there's also a lot of games that just weren't getting made, and they weren't getting made because people had either misgivings or misunderstandings of what a modern computer really could do. Because at that time, a modern PC, people were starting to ship 8-core CPUs, and the games weren't using them; they were only using 1 or 2 CPUs. And it was really clear to us that there was an enormous amount more potential that was just there, and it was already shipping. People already had it, and their games really weren't using it. And that was manifesting itself in a way that, like, a lot of game designers were restricting what they could do to the technological limitations of the engine. And so one of the founding principles of Oxide was to really get into the types of games that weren't getting made, games that people wanted to play, but for whatever reason, the technology was a barrier. And if we invested in specifically the technology for the types of games we wanted to make, which were strategy games, we could build a technology base that was just ideally suited for making the types of games we want to make. And the games that we want to make were wide open, open-ended, procedural, games that didn't want to bind the player to a preconceived game. So that was the idea when we started it. And so really the idea was just, the realization was just that there was just potential there that wasn't getting used, and we thought we could use it.
That makes sense. What about the history of it? Like, I heard you worked closely with Microsoft in order to develop the first version of it.
Right. So you rewind 10 years ago, and the industry was in this state where we had some great technology on DirectX 11, which every game was using. Even today, DirectX 11 is still widely used, and it had a lot of great potential. But one of the problems that we saw it when working on Civilization 5, because we really tried to push the envelope, is that one of the problems with that technology base is that you could not talk to the GPU with more than one CPU. So you couldn't what's called build command buffers up with more than one CPU. So what it meant is that engines had to be dictated along this what we call functional threading model, where you had one CPU core do one job and another CPU core do another job, and you couldn't really spread it across all the CPUs. And we tried, and it turned out that there were some architectural problems inside the way that Windows was presenting the API to us, and it really required a radical rethink of how the underlying technology worked. And so we had done some prototype work with AMD on a piece of software called Mantle, which was their very console-like. It looked like something that you would get on an Xbox API, and it was incredibly successful. So then Microsoft took that. AMD gave that actually to the OpenGL guys and to Microsoft and said, this is the proof of concept we have. And then we worked with Microsoft to take that technology base and build out the first version of Nitrous, which was the first game to ever use DirectX 12. And Microsoft used our code base and worked with us as a kind of textbook example of how the next generation of APIs should work. And so the cool thing about that is we ended up with an engine that is a lot of people considered the sort of de facto way that you should build a next generation engine, or I guess now it's current generation engine. And that had a lot of benefits for us.
But how does that engine enable Aura? Like, what parts of the game are challenging to handle? What does it do?
And it's funny because we started the Aura project. I was like, I don't know. We have all this firepower in engine. It's like, I wonder if we're really going to need all this firepower to make the Aura game. And it's fascinating is we did. And I've been doing a lot of profiling work, and it's just amazing when we're looking at the CPU profiles and the GPU profiles, just how much stuff is going on. And the reason is really simple: is that Aura is a game about the world, and the world is big. It's really, really big, and we don't want to constrain people. And it turns out that when you're trying to have a less abstract version of the world, so we're trying not to be a board game and have more stuff going on, that when you have a game of the scope and size of it, it just requires an enormous amount of technology just to be able to handle a simulation of that size and a presentation of that size. It's the things that Nitrous really brings to the table. There's a couple of, and I'll talk about a little bit of features that allowed us to really exploit what the system could do. But yeah, Aura, I can safely say it probably wouldn't have been possible, at least in the way its current form, without the Nitrous engine, without some of the work that had been done in DirectX 12.
I see. Okay, and then with DirectX 12's features, like, what about that is being used in order to enhance the player's experience in Aura?
There's two really, really important things that we use in DirectX 12, and there's a bunch of secondary features but it take too much time to get into them. But the two things that DirectX 12 that we really exploit that are critical, one is it's called asynchronous command buffer generation. So DirectX 12 allows you to build, let me back up a little bit. A GPU is a secondary processor, or second processor in your machine. And the way it works is that you build what's called a buffer of commands, so a list of orders to take. And you give it this list of orders, and then the video card starts to process those orders. On prior generations of technology, or a lot of engines still work this way, the building up of that command list only can happen on like one CPU. So it has to only happen on one CPU. And obviously, if you've got 16 CPUs, that sort of sucks, because only one CPU can be building this list of commands to do. So the big innovation of DirectX 12 was that you could have these command lists were designed in a way that you could build them in pieces or multiple ones of them, and on all the CPU cores. I think that we generate hundreds of them, and we're on all different cores, and then we string them together. And that was a huge upgrade from what we had been doing before, because that allowed us to spread the work across pretty much the entire system that we had available to us. That's the first feature that was really, really critical for us. Like, it's safely said, I just don't see how it's possible to have made Aura if we couldn't do that. The second feature, which is a little more technical, is something that AMD called back when it was first done, called asynchronous compute, but it's supported by both NVIDIA and AMD. And the idea here is that the GPU is a very complicated machine. It actually has thousands of its own mini cores going on. It's a very complicated thing. You can have entire college degrees just trying to understand the architecture of these things. But one of the things it turns out is that in addition to a single command list, it turns out that the GPU, under certain conditions, can actually work on multiple command lists at the same time, simultaneously. And the advantage of this is that sometimes there are certain tasks on the GPU, like rasterizing trees, that are using different resources than, say, something doing a computational thing. And if the GPU has different lists to work on at the same time, it can keep itself busy. So if one part of the GPU is not really doing anything, then it can load that and gets a better distribution. So we use the async compute feature quite a bit in Aura with the Nitrous engine, and that manifests itself really just an efficiency boost. So some of the cards that we profiled on, we were getting like a 20% gain by doing this. So yeah, it's quite substantial. Now, is that absolutely critical? No, but obviously that makes the game better experience for people. I don't know about you, but I would definitely take a 20% perf increase if it was just a piece of technology that just was software that allowed me to do that.
Well, then I'll ask you this as a final question for this. What are you most excited for players to see in Aura?
The most exciting thing for me about it is we wanted to go into a genre, and I always describe Aura as like, imagine you're describing a Granite 4X strategy game like Civilization to someone who's never seen it, and say, implement this game. And so one of the things we really are excited to see is like what happens when you can really use the potential of the system and offer a game that is a lot less abstract than a lot of games in the genre space, that's really bringing the world to life, and just push the envelope of what can be seen before. Inevitably, one of the things that we've noticed in our career, which makes game development both terrifyingly difficult and also exciting, is that you need to always offer people a new experience, something they haven't seen before, something that's compelling. I mean, we don't want to keep playing the same game over and over again, even if it gets progressively more refined. Yeah, we're really excited to show off our vision of what a modern strategy game can be.
Thank you so much, Dan. I've had the chance to see the Nitrous Engine in action while playing Aura, and hopefully the fans will soon.
Oh, thanks for having me. It was great to talk about all this really technical stuff, and I'm really looking forward to the feedback that our fans are going to send us.
And thank you to our fans who are watching. We've got a lot more in store, so be sure to subscribe to our YouTube channel for future Dev Diary episodes. You can also follow us along on your favorite social media platform and join our Insider program for a chance to be able to play the game before it launches. And don't forget to add Aura History Untold on Steam. Lastly, we are giving away PC Game Pass codes on our Facebook page every single Tuesday, and another code is going out on Twitter every single Wednesday, so be sure to follow along and answer each week's prompt to enter for your chance to win. Thank you, all of you, and we will see you next time.